Hello everyone, and welcome to Stats Kingdom. In today's tutorial, we're going to have a look at how to solve confidence interval problems. Take the following scenario. Bob is a farmer, managing an orchard. He wants to know a bit more about the weight of his apples, so he picked a sample of 30 apples and weighed them one by one. He found out that the sample average apple weight was 131 grams, and that the sample standard deviation was 12 grams. So what does the population mean? Well, we really don't know. In order to know the true population mean, we would have had to weigh all the apples, and we don't have access to that. We only have access to the weights of 30 apples. Okay then, what is the confidence interval for the mean with a confidence level of 0.95? Well, that's something we can answer better, because it doesn't ask us to state the population mean specifically, but it asks us to use the data that we already have to get a good idea of where the population mean lies. So in order to calculate this, we'll use the confidence interval calculator at statskingdom.com. And we'll plug in our data. So first we look at the confidence level, which we can leave at 0.95, but we could change it otherwise if we want something different. We don't know the population standard deviation, so we can leave that blank. Then we look at some of the sample statistics. And the average was 131 grams, so we write that in. The standard deviation was 12 grams, and the sample size was 30 apples. And once we have all of the numbers plugged in, we can click calculate and get the following results. So first we can see the confidence intervals above in APA style. And next we can see some measurements about them. We can see the margin of error, and we can see the standard error. Also, since the population's standard deviation is not known, the formula actually used t-distribution with n-1 degrees of freedom. So what does this confidence interval actually mean? It means that if we were to calculate the confidence interval over an infinite number of samples with the sample size 30, then 95% of these calculated confidence intervals will contain the mean's true value. Underneath this, we have the derivation of the confidence interval for anyone interested. Next, we might want to check out a confidence interval for the standard deviation. So if we scroll down, just underneath it, we can see first of all the confidence interval for the standard deviation, and also a confidence interval for the variance, if we need to. And again, like any confidence interval, this means that if we calculated the confidence interval over an infinite number of samples with a sample size of 30, 95% of the calculated confidence intervals will contain the standard deviation's true value. And again, we have the derivation below, which uses a chi-square distribution. Okay, so let's say that the problem changed a little bit, and we discovered that the population's standard deviation is 18 grams. So we can go back to the calculator and put this new information in under population standard deviation. And press calculate. And once again, we can see the confidence intervals in APA style and some information about it. Now you can see that it's a little bit different than the one before. Because here, since the population's standard deviation is known, the formula uses the normal distribution rather than the t-distribution from before. And again, we can see the derivations. And also, we have some information about the standard deviation confidence interval and what it might mean. Now, since the population standard deviation, 18, is not in the confidence interval, there's a high possibility that the population standard deviation is not correct. And that's what we can learn from that. Now if we had different data, if we had a random sample of banana weights with the following weight, we can then copy this data and go back to the calculator. And instead of enter summarized data, we can enter the raw data. Now when we have that, we can either include or exclude outliers, but it's usually preferred to include the outliers unless you have a good reason to do otherwise. So we can paste the data separated by either commas, spaces, or enters, it doesn't really matter, and press calculate. And also we can also, rather than paste the data like this, we can paste it from Excel. Now what we're going to get is the following. First of all, we'll get some sample statistics. So this is handy if we don't want to calculate the average ourselves. We can just put the data in and get the average, the sample standard deviation, and the sample size automatically. And also we get some additional parameters that tell us about whether it makes sense to calculate the confidence interval for data like this by outlining the skewness, the normality p-value, which tell you if our sample is part of a normal distribution, and again, any outliers that might be present. Okay, and given this data, we can once again get a confidence interval for the mean with all the relevant information, and a confidence interval for the standard deviation, again with the derivations and with the relevant information. And we actually have an additional feature, which is to get the R code for calculating these values. So if you need to include R code, perhaps for a paper that you're writing, you can use the following. Thank you very much for listening.